All right. Hello, everybody. You know the routine if you've tuned in before. Take a few minutes to let the URL propagate around the internet, and then we'll be ready to go. But good afternoon to you as you join in. Share. For those of you just joining in, I am tweeting out and otherwise posting the live YouTube link. Feel free to share it yourselves. That's fine. And now for Twitter. All right, Ben, you should see it.
Excellent.
Yeah, get me framed up in the shot. All right, 76 people tuning in. Good to see you guys. We'll get started in just a moment. We'll wait for a few more people to join in, and then we'll be good to go. And absolutely, feel free to share the link. This is publicly available to anybody, so you all may share the link on your social media. Not a problem at all. And if you have to step away and you're going to miss any part of this, do not worry. It'll be archived and saved and all that good stuff. We'll get started here in just a couple more moments. Give this time to propagate around the world, as they say. One more minute. Yeah, this is Hurricane U. That's what we call this. It's my little cute little way of creating an educational platform. Got to have a name for it. So we call it Hurricane U, kind of like ESPNU, but theirs is more for college sports, I guess. But you get the idea. This is a learning platform trying to expand your mind on some of the different topics that you hear me talk about in the Hurricane Outlook and discussion videos, bringing in many cases, the very people that I cite via Twitter and elsewhere on social media, kind of hearing it from their mouth, and it helps us to learn more about what we're talking about. So with that being said, let's get the Zoom up. Fantastic, this stuff seems to work. All right, so it's a little after 5, about 5:06 Eastern Time on Friday, July 17th, and this is Hurricane U. I'm your host, Mark Sudduth. Appreciate you tuning in. This is a supported by Patreon event. You guys are all making this possible that are supporting us through Patreon. We appreciate that, and we're going to get right to it. This guy right here, it's kind of early in the morning where he is. This is Ben Noll. You know him, Ben Noll Weather on Twitter, the Hudson Valley weather extraordinaire guy. Lots of snow forecasts, school closings. Well, we used to have school closings. Maybe we'll have those again someday here in the United States, you know, for snow rather than other things. So this is Ben. I'm going to let Ben just do a quick introduction about who he is, what he does, and when he's done with that, then we will get into it. So Ben, tell us a little bit about yourself, please.
Thanks, Mark. Yeah, my name is Ben Noll. I work for the National Institute of Water and Atmospheric Research here in New Zealand. It's called NIWA. And we are the National Climate Center here in New Zealand. So I guess akin to the CPC in the United States. And I lead NEWA's seasonal climate forecasting project, which produces operationally 3-month outlooks for New Zealand over the next, of course, season. So, of course, when you're doing seasonal forecasting, it goes above and beyond, just your borders. You have to look abroad to understand climate patterns. And since I'm come from the U.S., I used to work at AccuWeather.com. I still keep very much in touch with the weather and climate that's going on in the States. Right. And one of my main interests, the reason I'm here today, is to talk about tropical storms and hurricanes and what we might expect over the next couple of months. So always enjoy being on with you, Mark.
Well, I appreciate that. And again, you heard that right. He is in New Zealand, where it is a little bit after 9 a.m. on Saturday. So through the magic of the internet, we're talking to somebody who's in the future. So ponder about that a little bit. Time travel, there you go. All right, so let's get right to it. Seasonal forecasting, we have the outlooks that we get from the likes of Dr. Phil Klotzbach and his team from Colorado State University. That is perhaps the most prominent group that we've heard from over the past, I think, at least 3 decades. Over the years, others have joined in, NOAA, private companies, on down to individuals. I mean, anybody can make a forecast and give it a shot, and there's probably office pools and message board polls and all kinds of things. And then there's sort of the sub-seasonal forecasting tools that we look at. 2 weeks out, 30, 40 days instead of months necessarily. And that's what we're really going to focus on here today, is some of these tools that we see Ben create. And he actually makes these maps from available data, and then he tweets those out, and I talk about them on my discussion. Other people pick up on those, and we're going to try to break that down and understand what we are looking at. And the goal is not to make you that are watching a trained meteorologist when we're done, but at least you understand a little bit more, maybe in layman's terms, what we're looking at, why it's important, and a little bit about how it works, kind of peeling back the covers a little bit and understanding it a little bit better. So, with that being the case, Ben, where would you like to start?
Yeah, I think it would be good to start, Mark, and thanks for that introduction. To maybe talk about the founding fathers of seasonal forecasting and kind of where this all began, because I think on Twitter nowadays we see all these pretty maps that may show ocean temperature anomalies or pressure anomalies or rainfall anomalies, but maybe to give people a better appreciation of how this has evolved over the decades. And it really all started in the 1970s. That was when we had kind of the seasonal forecasting founding fathers. There's 2 names that come to mind, Jerome Namias and Russ E. Davis, the latter coming from Scripps, and their initial research focused on ocean temperatures and how that influenced pressure in the atmosphere. Sure. So it was a research focus, very early days, 1970s. But then came the El Nino event of 1982-83, which was a catastrophic failure. The meteorological and climatological communities failed to identify this major El Nino event in the early 1980s. And that actually led the community down a variety of research pathways, one being called the Tropical Ocean Global Atmosphere, TOGA, a research group that wouldn't allow that type of failure to happen again. So throughout the 1980s, that research went on, and that continued to be seasonal forecasting, a research exercise right on into the 1990s. Right. But once we transitioned from the 90s to the early 2000s, that's when things became a little bit more open, and there were global producing centers that were showing their maps, their seasonal forecast data on the internet. And then, of course, as we went through the 2000s, the modeling has gotten so much better because we had more observations in the ocean. A lot of the predictability, the vast majority of it, comes from our ability to observe the anomalies within the ocean, sea surface temperatures. And that has continued to grow through the 2000s. And our computing power, obviously, has increased dramatically through that time. And here we are today in this golden age of sub-seasonal and seasonal forecasting. So we've got the weather, I think, time scale. Of course, day to day, there's times maybe in a month there's 2 or 3 days where you might, say, hey, the weather forecast was trash today. But
Right.
overall, we've got the weather forecasting in spades. But
Agreed.
what I like to say is that climate is kind of the new weather. This is where we can insert ourselves as forecasters into the loop and try to improve the outputs that we're seeing, or make decisions, planning decisions based on the outputs that we're seeing in the subseasonal to seasonal space, because there's still more room to grow there.
Hey, there you go, everybody. There's your history part of it right there. That's perfect. And he says it so well. That's amazing stuff, and how it's evolved over time. And we see the maps that Ben will tweet, and other people put them out. Jack Sillen from Weather Models. You see it, Ryan Maui and others. And these maps really help to tell a story. We call those thematic maps. That's a geographic term. And they're very important because they help us to understand and visualize. Visualization is the key to kind of taking complex concepts and wrapping our brain around them a little bit easier. All right, so where should we start in terms of some of the awesome graphics that you've put together? And as you do that, I might even jump in and interrupt you. It's going to be harder to do since you're like 12,000 miles away, but I'll try to interject and say, almost like me, hey, Ben, I've got a question. There we go. I got a question. What does velocity potential mean, or whatever? Maybe he brings up a term. I'll stop him and we'll try to understand that term as best we can. But we don't want to keep him too long because it is his day off there. It is Saturday in New Zealand, so we'll try to keep this going at the same time. So where do you want to start from there, Ben?
Thanks for that.
Yeah.
Yeah, thanks for that, Mark.
Got to get everybody in my house off the internet. Da-da-da.
And everyone here is tapping into that same line. So around 8 p.m., 9 p.m. in the evening, our internet speeds here in New Zealand.
Or maybe somebody ran into a telephone pole and knocked out my internet. Waiting for it to come back. Let's see. How are we looking on the chat? You guys tell me on the chat. Are we back? Are we buffering? Is it unusable? What's up? Trying to ad-lib my way through this. It's back and just blurry. Oh, sorry. Looks pretty good on my end. All right, well, let's try to keep going, fight through it, ad-lib our way out of it. First graphic here. Well, there it goes again. Well, this sucks. Come on. Been worst case scenario, if this doesn't work live, I'll just set it up to record and then we'll just play it back.
Okay, sounds good. Well, we'll shall we go for it, or?
Yeah, let me let's see. I'm trying to, there's nothing that I can do. If it's the neighborhood
right
filling up with people sucking up my bandwidth, then I'm pooched. There's absolutely nothing I can do. And so it might be best for me to kill the live feed and then just start over, record the whole thing like it's live, and then put it out as soon as I can. Because I'm still getting the little buffering circle. And I know it'll irritate people that are wanting to see it live, but we want it to be the best that it can be as well.
Yep, totally.
And they're saying it's live. They're saying continue, go. But I've got the little circle showing that it's buffering. And now it's off again. Let me just check. Make sure.
I've gotten confirmation that a viewer can see the map. I guess maybe it's situational.
All right, you know what? We'll shut up about all that and just keep going forward, and we'll hope for the best. All right, and I tell you what, if it absolutely crashes, we'll do a truncated version where we start over and I'll record it, and we're going to make it look good. That's the bottom line, is I want this to look good, but I also don't want to waste Ben's time. It is Saturday, and the guy has equally important things to do. We'll say that. I know he loves the weather, so we'll say it's equally as important. All right, so Ben, what are we looking at here? And we'll keep our fingers crossed that this moves on despite the lack of zeros and ones going through the air. What do we got?
Yeah, sorry for that delay, but we'll jump right into it. We've got ocean temperature anomaly. So this is the skin of the sea surface, temperatures being anomalously cooler than average for a series of several months before we are officially in La Nina. But nevertheless, the atmosphere can lean in one direction or another, in this case toward La Nina, and it has displayed some tendencies that are La Nina-like over the last couple of months. So that's one important piece of the puzzle here for forecasting around the world, because we know that El Nino, La Nina account for about 25% of the climate variability. Depends on your location. That's what we experience here in New Zealand. About 25 to 30% of our climate variability is driven by ENSO, El Nino Southern Oscillation. So that's one piece of the puzzle, Mark. The other piece of the puzzle here is all that warmth that we see in the Atlantic Ocean. Warmer than average ocean temperatures are extending from west of Africa, and we see them warmer than average in the Gulf of Mexico, right up the eastern seaboard. And that's critical as we are now moving into the peak of the hurricane season here from August into September.
Right. And this is a different perspective. In case you're wondering, you're like, what am I looking at? So here's the west coast of South America. There's the La Nina signal. Well, it's almost, it's colder, cold neutral, whatever. That's the cold sea surface temperatures. Here's the west coast of Africa and the warm Atlantic. And so how do we get these temperatures? Is it satellites? Is it buoys? Is it some guy dropping a thermometer down into the ocean? Is it a combination of the three? Because that's pretty important that this is accurate, isn't it?
Yeah, that's right. There's a variety of ways that we now here in 2020, fortunately, we have so many different data sets that come together to create a pretty map like this. There's satellite-derived SSTs, so that, satellites that are orbiting the Earth have the opportunity to understand what the temperature of the ocean is. We have buoys across a variety of the tropical oceans as well. There is something called Argo floats. So these are these profilers that sit across the ocean and all over the Indian Ocean, the Atlantic Ocean, the Pacific Ocean, that measure the temperature. And we have the ability to not just do that at the surface, but at depth as well in the ocean. So these things can be sent down several hundred meters to understand how the ocean looks from the top down to the bottom, because It's actually important to understand what's happening beneath the surface as well, as that can often tip the hand as to what the surface may do in the upcoming couple of months.
All right, so we are pretty confident in the sea surface temperature pattern, and we know we have a warmer than average Atlantic, a colder pattern in the equatorial Pacific, no El Nino. That is absolutely 100% certain. We're not going to have an El Nino August, September, October. And the Atlantic is warmer, and I don't think that's going to cool off dramatically. There's no indication of that. So that leads us to the next map you're getting ready to pull up there, the upward motion. All right, so this is where we'll jump in. And first of all, let's talk about, and it says it right there, velocity potential. And if you can bring yourself back up, Ben, so we can see you and you can play professor here. What is velocity potential, please, sir? How do we understand that?
So velocity potential helps us to understand how the atmosphere is reacting to those ocean anomalies. Velocity potential actually something that a field that was, I think, in the late 1700s was the first time this was discovered by a mathematician. And here we are in 2020 using it to help us understand atmospheric patterns here. And what it is kind of ENSO's atmospheric buddy. It helps us to understand the anomalies in the Walker circulation. So where we see, if I go back to the map, because that will, I think visuals are quite important here. So we'll go to the PowerPoint, share. So where we see the green shades on this map show increased upward motion, lift in the atmosphere. And lift in the atmosphere, in this case, corresponds to upper air divergence.
Okay.
And upper air divergence at the top of the atmosphere is a pattern that is favorable for thunderstorm development. And we see that over top of Africa. This is from the 1st of June through the mid part of July. It has been very persistent over the African continent, and that has led to a very active African monsoon period here over the last month or so. In tandem, we have this large area of suppressed convection and rainfall over the tropical Pacific. And that is in response to the colder ocean temperatures that we were just looking at on the previous slide.
Right.
So that tells us that the atmosphere is reacting to those colder than normal ocean temperatures in the Pacific. And the atmosphere likes balance. So if there's sinking, anomalous sinking or suppressed convection in one part of the world, well, what goes down must go up somewhere else. And in this case, it's going up over Africa, and that could have implications on the upcoming, we're in hurricane season, that could have implications as we go into the heart of the hurricane season.
And so this graphic that we're looking at here, it says 1st of June to the 15th of July. So this is how it has been observed up until now, basically. Is that correct?
That's right, Mark.
All right, so the green off of Africa here, and this is a Mercator projection map, and it might be a little hard to pick out translating through our limited bandwidth or whatever. But yeah, this is the west coast of Africa over here, the Atlantic main development region, and then all of this orangish color is the Pacific. And you can see all down in the tropical Pacific, and then you can just, hey, we haven't had the first Eastern Pacific hurricane yet, and I can't even remember the last typhoon. The West Pacific has been shut down. This is the Indian Ocean over here, the east part of Africa. It'll be really amazing when we can have like a hologram of a 3D world and we can just turn it or whatever. But this will do for now, this flat map. Sinking in the middle here, the tropical Pacific, most of the Pacific, rising motion over Africa. So this is what it's been so far. This is how things have been so far. Even though we've had tropical waves coming off, they have not developed yet in the main development region. And why is that, Ben? How come we've got a robust monsoon signal, but no named storms or even depressions out in the MDR just yet?
Yeah, so there's been a couple of things, Mark. Earlier in the season, of course, we had that big outbreak of Saharan dust that came across the Atlantic. Which was not favorable for tropical cyclone development, dry, dusty conditions across the Atlantic. But that's pretty typical for the early season. We've had quite a bit of stability, so not a lot of instability across the Atlantic Ocean, and that is connected to the velocity potential that we're seeing here. So the pattern of suppressed convection has impinged that suppressed convection we see across the Pacific has impinged upon the Atlantic. And lately, we're seeing suppressed convection now emerging over South America as well. So as these systems have come out of Africa and moved further west, they've run into a general area of unfavorability in the atmosphere.
And that's pretty typical for July. That's why, if you know the peak, you guys know that graphic where it starts out slow, then in late August it ramps up really quickly and then comes back down again. We're not supposed to have a lot of hurricane activity in July for a reason. And it's a slow process. The background state takes time. But what I'm seeing is, and maybe we can go to a forecast velocity potential. This is what we've had. This is where we're heading. So this is from today through almost a month from now. And you're going to see it's like we know that the background state slowly changes in any hurricane season. It gets generally more favorable. Even in the most harshest of El Nino years, the background state of the Atlantic basin eventually becomes conditionally favorable. And then on top of that, you add some of these other features like a lot more sinking motion if there's an El Nino and other factors. In this case, the background state is going to become naturally more favorable, and then superimposed on top of that in a big way is this. And so what are we looking at here? This is the forecast, I would assume. This is weeks 1 through 4. It looks like it's going to slowly start to crank up.
Yeah, I think that's what we're expecting, Mark. And what we've got here, this map is overall an average of the next month. So when we actually, it would have been better if I actually created a bit of an animation of this so you could see how each of the weeks of the next 4 evolved to something that looks more favorable for tropical cyclone development once we get into the first 2 weeks of August. Because what we can see here is actually a suppressed cell of convection and rainfall over South America.
Right there.
And that's actually expected to be most dominant over the next week to 2 weeks.
Okay.
As we're seeing this move across the Pacific now, and then that will emerge over the western part of the Atlantic. So say the next 2 weeks through the end of July, give or take, there will be tropical waves that move off of Africa into the Atlantic Ocean, but they're going to be then battling this unfavorable, what we call intraseasonal state,
Gotcha.
which is that suppressed convective cell. However, as we go into the first couple of weeks of August, the first 2 weeks of August, there are some signs, and again, if I had an animation of this, you'd be able to see that suppressed cell over South America and over the Western Atlantic gives way. It gives way to that area of rising motion over Africa, which kind of pushes westward farther into the tropical Atlantic. And that is the expectation, not just climatologically, as Mark was describing, but also for a more favorable than normal status as we work our way later into August, and then of course into September, which aligns with the peak of the season.
So this up in the corner says JMA. What is that? That's one of the weather agencies. I know what it is, but so talk a little bit about where this comes from and how reliable it is compared to the others. I know you like to reference the ECMWF, the UK Met, and this is the JMA. What exactly is the JMA?
Yeah, so the JMA is the Japanese Meteorological Agency, and every week they produce an outlook that goes out a month. So they publish raw model data, and then I take that raw model data and make it into a map that tells a story. Mm-hmm. So the Japanese Meteorological Agency has a pretty good track record, and I will say that recently they have made an upgrade to their velocity potential prediction. So this very field, by one of the ways they did that was by increasing the resolution of their model.
Sure.
And it made their forecasting better, even in the sub-seasonal space. So it's one of the tools that's on the tool belt. Of course, model guidance in general, it's guidance, not gospel.
Yeah.
So what we take here, we look at it and we try to interpret what it means. And sometimes those interpretations don't always work out. As we know, we're still learning in the sub-seasonal and seasonal space. However, we can use signals to help us do things like planning. So this is most useful for people that are doing forward planning, like farmers, like people that are preparing FEMA for the hurricane season that's upcoming.
Yeah, like we talk about, that it's an indicator of what could be coming, and it's almost like a symptom, if you will. I mean, there's a lot of different ways to look at it. And like Ben said, it's a tool in the tool belt. It's not the tool. It is not an absolute forecast for what is exactly going to happen. This paints the picture almost literally with these nice colors and the gradations of those colors as to what this particular model is suggesting will happen with the wind in the 200 millibar level of the atmosphere, whether it is sinking, which is that suppressed phase, because sinking air squashes cloud formation, and that's this color all through here, or is it going to be rising better, more divergent flow aloft, so that those thunderstorms can grow, spread out evenly, and continue that feedback mechanism that lowers the pressure in these tropical systems and gets that engine off and running in a very efficient way. That is what this green shows. And the African wave machine, the tropical waves, are going to be robust, because I'm assuming this goes past August 15th. Like, you've got more? We can continue to look into the future?
It does, and we can look into that crystal ball out to 6 to 12 months, depending on the model, Mark.
Right.
So we will take it even further, and this is the outlook for September from the ECMWF. So we're switching models here. This is the European model, the seasonal model that I think a lot of folks that are into the weather would have heard of the European model. It's the best performing model long term that we have on the weather time scale, but it also produces seasonal outlooks that go out about a half a year. And what we're seeing here is the same field velocity potential for the targeted on the month of September. And we see a pretty similar theme to what was shown in the month of August by the JMA guidance. And that is a lot of rising motion over Africa. Mm-hmm. So that keeps that African wave train going and perhaps even more active than normal. Right. And once we reach September, climatologically speaking, our SSTs are at their peak. The ocean temperatures are at their peak. Wind shear is climatologically at its lowest point. Yeah. And then when you put that together with an active African continent, even if you have this signal for sinking motion over the Atlantic or near South America, that can overwhelm that signal. So we might see that these systems just, move off of Africa and then, continue to strengthen as they move across the Atlantic, just because of how strong that signal is over Africa. So that sinking motion over the Atlantic here, we'll have to see. It's more of a sub-seasonal. Once we're getting a lot closer now to be able to see on the sub-seasonal time scale, things like, as we'll probably talk about soon, the Madden-Julian oscillation. Right. These are things that inside of a given season can influence favorability for tropical cyclone development. So this is a broad picture, but within that broad picture, there is more detail. And as we get closer to September, we'll be able to pick that out.
And is this happening more or less because the sea surface temperature pattern in the tropical Pacific is cooler this year and the Atlantic is warmer, among other things? But are those two big drivers as to why? Is it cause and effect? Is it, quote unquote, that easy? I know it's more complex, but is that one way to look at it, that, you got your colder look in the Pacific, warmer Atlantic, this is what you would expect to see as a result, more or less?
Yeah, in the tropics, what we were talking about earlier, the Walker circulation, it's a thermally direct circulation, which means it's driven in a broad sense. Well, it is driven by ocean temperature anomalies. So that's why predictability in the tropics is much higher than it is in the mid-latitudes, as the processes, the meteorological processes that happen there that drive the weather are simpler in nature than what is, causes the weather patterns in the middle and higher latitudes. Right. So we can really use that to our advantage when we're forecasting here in the tropics on a seasonal timescale.
So what do you got next? All right, this takes us through September on the ECMWF, and that's velocity potential. Now we have the JMA, the Japanese Meteorological Agency, Precipitation Anomaly. And remember, anomalies is just our way of saying a departure from the mean or the average or the normal, whatever normal is. And I like these very easy to understand colors and then the gradations of such. The greens are more and the brownish colors are less, generally speaking. So this looks, when you kind of boil it down, tropical cyclones dump what? Rainfall, precipitation. This is very interesting. So describe what we're looking at here and how this kind of piques your interest as to what may happen.
Yeah, so this is the JMA precipitation anomalies, rainfall anomalies over the next 4 weeks. And what we see in the greens is above normal rainfall, browns below normal rainfall. So it's a pretty simple map to interpret. Right. And we see the signal off of Africa for very wet conditions. Now, there are a number of disturbances that have rolled off of Africa to date that have fizzled out as they've moved further west and ran into this unfavorable atmospheric state for development. However, what's interesting in this map in particular is the area of above normal precipitation that extends north of the islands and over South Florida and into the Gulf of Mexico. I think that might be an area that we need to watch as we go into the month of August, maybe not over the next week or two, but as we go into the month of August, that could be a signal or an area to watch for possible development. And even though our patterns over the next week or two are not particularly favorable for development over the deep tropical Atlantic, remember our ocean temperatures near the east coast of the U.S. and in the Gulf of Mexico are warm enough to sustain the tropical development at this point in time.
Oh, big time.
So
Yeah.
even if we don't have, if we don't have the opportunity to see anything in the deep tropics over the next week or two, keep an eye closer to home, as there may be some, homegrown type development over the next couple of weeks.
Yeah, and that gives us less time to be ready. Remember back in 2005, Katrina, of course, came from one system led to another system. You remember how that evolved? If you don't, you should go back and read the history of Katrina. But it really got its start once it got going up in the Bahamas, and the entire process from the Bahamas to landfall in Louisiana, Mississippi area was only about 5 days. All right, Rita was a very similar evolution through the Florida Straits. Wilma was a little longer in its evolution. But some of these that are much closer to home doesn't necessarily mean, look at Michael, coming up now on 2 years ago this October. Michael was Yucatan Channel to landfall near Mexico Beach in a matter of just a couple of days there, and it made it to Category 5. So don't be fooled that thinking if it's closer to home, you can't have an intense hurricane, because you absolutely can. And that's an interesting, what do you think, Ben, is the reason? If you had to speculate, and there has to be a way to kind of interpret, why does the JMA think, in air quotes there, think that there's going to be a pretty solid, that's a pretty definitive stripe of positive anomalies? Why does it think that, so to speak?
Yeah, so when we process subseasonal modeling or seasonal modeling, there's a lot of ensemble members. So what you're doing is running one model, say 10 times or 20 times, and then you're taking the average of that, and that's what you see here. However, what sits beneath that average is perhaps a couple of models that are showing intense cyclones that are either moving through that particular region that are producing an anomaly in terms of above normal rainfall. So where you see the brighter colors here, the brighter shades of green, that gives you probably a higher confidence as to multiple ensemble members picking out a general region of interest.
Wow, that's very interesting. So and I like that term, the gradation here, that the darker color in the gradient here of the green that he's using, that's eye-opening. We got to definitely keep that in mind. And then off of Africa here, some very strong tropical waves. Maybe they die out closer to South America, and then they kind of resurge again. And we saw that in 2017 with Harvey. You guys remember that? Of course you do. Harvey came across, died out, came back, and it made history there in Texas. We remember how that evolution went. That just because they don't make it all the way from, 40 degrees longitude all the way across to the U.S. shores or Mexico or the Greater Antilles, those breaks in between where they die off and come back, we've seen them do that before. That's really, really interesting, and that takes us through about the mid part of August. All right, so now we're looking at about, I like this, Ben calls this the super blend. And this, to me, wow, this really opens my eyes, because it certainly is outlining potential tracks. The models are seeing something, aren't they?
Yeah, and the interesting thing, Mark, is when you and I were sitting here about 2 or 3 months back when we did our first tape, the guidance looked kind of just like this. There's been this long-standing signal for what is a very active period this year between August and October. And that's been not just one model, that's been across several models. So as a forecaster, when you sit back and see that, it's different models that are derived differently, that are run by different centers. Each model may have its own bias, but when you're seeing several models singing the same tune that are coming from different places, that is a red flag. That's a flag. That is something, we really need to focus on this. And what we see here, what I like to do is combine the ECMWF, a well-known seasonal producing center, and the UK Met Office, another well-known seasonal producing center. And this is a 101 member blend. So the ECMWF, 51 ensemble members, the UK Met Office, 50. They do it a little bit differently how they derive their members in the EC. Nevertheless, when you combine it all, mix it up in a pot, it gives you quite a signal over the Gulf of Mexico as we work our way from August through October, above normal rainfall pretty much across the board. So that's suggesting that many ensemble members are quite busy in that region, Mark.
Yeah, and this little area right off the west coast of Florida, that's eye-opening. Okay, we got to pay attention. That's really interesting. Then this area right up here along my neck of the woods off the east coast and the southeast, some Bay of Campeche action, and then maybe an implied potential concentration just south of Mississippi, southeast of Louisiana, and then something we have not seen in a number of years, the potential for some Western Caribbean action. It's been really, void of activity in the Caribbean for a while. That's an interesting signal. And then, main development region, maybe some stuff dies off a little bit in the gauntlet as we know it. And then, wow, this is, it's going to be remarkable to go back when this is all said and done and look at the tracks. This is a keeper. Definitely want to hold on to that graphic and then overlay the tracks of what actually happened. And we got to revisit that in 2021. That could be a remarkable testament. In fact, it'd be neat to see last year overlay the tracks, see what happened. But especially this year, that's incredible. Does any of this surprise you? We don't like to say alarmed or worried because we're alarmed and worried about things when we don't understand them, and we fear what we don't understand. But does any of this surprise you? Because as scientists, we can be surprised, and that's what observation leads to, is the discovery of something, and sometimes that discovery is surprising, hopefully not alarming. We try to avoid that. But any of this surprising to you, Ben?
Well, Mark, we know that the climate drivers themselves are aligned with past years that have produced a lot of activity. So to that end, it isn't particularly surprising.
Okay.
What I will say is that a map like this doesn't tell you the whole story. It doesn't tell you how intense the weather systems that obviously it's showing will be. So for something like that, you would need to look at a different metric, be it, say, wind gust or accumulated cyclone energy. So these systems that it's showing, you don't know if they're a weaker system that's just producing a lot of rainfall or if they're a more intense system.
Right.
And that's something that we'll find out. That's more of a question for the weather time scale.
Right. That's true. That's a good point.
And I will also say that as you look at this map, even if your country or your region is not shaded in bright green, you're not skilled enough to identify on a seasonal scale exactly where each storm will go. So just because Texas is a varying shade of brown, that doesn't mean that you can't see a landfalling system in Corpus Christi and that moves up into Texas and produces a lot of flooding. That's still possible given the overall signal that we are seeing within the Gulf of Mexico, and it all depends on the individual weather pattern that you're experiencing at the time.
Right.
So while this map may look scary in general, there's a couple of key takeaway messages. It doesn't tell the whole story, but it does give us something that's quite profound to look at and consider for the August through October period.
Well, I know you're a fan of basketball. I've seen your basketball shots on Twitter. I like that, and especially this year with the absence of the completion of basketball so far. So we can put it into a way that everybody can understand. This kind of tells me that the team, if you will, has come to play. This team means business, and you better watch out because the team is loaded for bear. There's a lot of talent here, is the way you can look at this, but it doesn't tell you what each individual player is going to end up doing on that team, that the cumulative output would be a winning game from that team. And in this case, this shows a very active season. But to Ben's point, the details are not available just yet. This is seasonal, and as he's talked about, that's more along the lines of everyday weather, 3, 5, 7, 10, 15 days out at the most, probably. Very interesting, though, for sure. All right, what do you got next? This is fascinating so far. Very intriguing.
Yeah, so we've got probably 2 more slides here, Mark.
Steering, all right.
The slide I've got now is a pressure atmospheric height anomaly.
Wow.
So where you see the red shades is higher than normal heights or pressures in the atmosphere. And we see that in particular on this map over and south of Newfoundland and Nova Scotia.
Yep.
And during our active periods during the hurricane season, this is one area that we look for higher than normal pressure, as it can help to steer these tropical systems in a certain direction. In this case, that direction is toward the east coast of the U.S. So again, it's not meant to alarm, but it's more meant to show the different pieces of the puzzle here as we work our way into August, September, and October that are working in tandem to basically produce what is by forecast by many to be an active season.
Right.
And this one right here is often there was a comment, I think, with it called the ridge over troubled waters.
Right.
I've heard that. I've heard that made as a bit of a joke for this pattern. But overall, it can be associated with active conditions over the tropical Atlantic when you have that ridge to the north of the northeast U.S.
And so this is an anomaly chart. Again, this is heights in the atmosphere. Think about these bubbles of air, areas of air over the globe. Think of it like mountains of air and valleys of air. And the UK Met at the 500 millibar level indicating in its modeling here from July through September of this year, this little red area, this gradation here, what is that, about 25 plus meters thicker, and that's how the atmosphere is measured. We're getting into some meteorology here, but that's like a larger dome of air, more of a puffy, stout area of high pressure instead of, and look, you can see where the troughing is. The troughing is back here over Michigan, well, actually west of Michigan. It looks like Minnesota and Wisconsin. Your mean trough position right down the middle instead of off the east coast. If you add a lot of hurricanes coming out of the deep tropics to this signal, as Ben alluded to, it might mean a high landfall season coming up for what does form. That has got to be an attention getter and hopefully motivating some people to take action, especially this year with what we're dealing with already. You know now, this is what I'm talking about. This is the signal ahead of time. You can't say, well, I had no idea that was coming. This was telling us pretty early on. That's amazing, Ben. We'll see. That's amazing. All right, what else?
Yes. Yeah, so I think we've got one more here, and we're going to go global because we know that what goes on in one part of the world where there's high rainfall, as we've just seen in the Atlantic, well, there must be another region, Mark, that is not seeing a lot of rainfall. And to date, that has been the Western Pacific Ocean.
Yeah.
And this is a forecast from July to September, and we see well below normal rainfall to the east of the Philippines. And there's a couple of island groups in the Pacific now, Guam, the Northern Marianas Islands, to the northeast of Papua New Guinea, Kiribati, these small island groups in the Pacific that during La Nina events see some of the most devastating droughts. And this is what is unfolding, unfortunately, in that part of the world, some of these island groups. But it also is another signal that shows us that, well, the tropical activity in the Western Pacific is likely to be down. So understanding what basin that is going to pick up the torch, because what goes up somewhere must go down somewhere else. The atmosphere likes balance. So that really tells us that the Pacific Ocean, because of this La Nina-like pattern, is going to be suppressed in the West.
This is really interesting to me too. The curvature of the precip pattern. I mean, that is just incredible. You can just imagine the hurricanes, tropical cyclones, we'll just use the general term, coming out of the tropics, going around the subtropical high, and even curving out into the North Atlantic. There's enough little pockets up through here. You can see your curvature there. That is remarkable, and it is really going to be fascinating to go back and see, overlaying the tracks from 2020. We can do this, probably by November, you would think, November, December, and see how that matched up. And it could really help us to figure it out in years to come. But that's an amazing look. If you follow hurricanes, wow. I mean, what else? I mean, and this is not like this is April today. This is July 17th. This is coming soon, so to speak. It's not a guarantee, but this is a very, very substantial signal to be sure. Anything else you got, sir?
Yeah, look, I think before we go, Mark, it's always good to, we've talked about why things might be favorable, but let's play devil's advocate here. Let's go, what could go wrong with these predictions, because this is, far from a perfect science,
Right.
and as any good meteorologist or climatologist will tell you, we are always learning and applying those learnings to our models and to our research. So what could go wrong this season where things aren't maybe as busy as we had forecast? I think one of those things it would be if the Atlantic stays relatively suppressed through the month of August. We know that here late in July, that looks to be the case with that sinking cell, as we looked at earlier, over South America and the Western Atlantic. If that feature continues to be persistent into later into August and September, that could put a lid on things overall. Not saying that that's going to prevent all hurricanes. That
Right.
certainly won't be the case. But if there was something that would keep things maybe a little bit lower, that's one thing. A second thing that I've been keeping a watchful eye on is a relative lack of something called Madden-Julian oscillation activity. So I'll break that down in the last few minutes that we have. The Madden-Julian oscillation is an eastward moving pulse of cloud and rainfall that is the single biggest driver, influencer of weather across the global tropics. So within a season, the Madden-Julian oscillation can be in different parts of the globe. And we know that when the Madden-Julian oscillation is over the Atlantic or over Africa and the Western Indian Ocean, what we call phases 8, 1, and 2, it tends to promote busy, active conditions over the Atlantic, favorable for tropical cyclone development.
Right.
But there hasn't been a lot of MJO activity in the last month or two. It might be owing to this large area of suppressed convection that's over the Pacific. So those MJO events have kind of been halted, even though they have developed at times in the Indian Ocean. They've been halted from progressing further east, marching their way across the Pacific and then emerging over the Atlantic. And we often look for that to create a flurry of activity. So that will be another thing that's interesting to watch if that activity isn't as robust as we've seen in the last couple of years when the Pacific was warmer. That could also perhaps put a lid on things. But overall, there are more indications that things will be becoming active than not. But we have to look at the whole picture here, because there are a few things that are worth noting toward the less busy side of the equation.
Yeah, I mean, but like you said, it still seems to be the overwhelming signal. And this is certainly one of the strongest signals that we have seen over and over again of the last several years. And speaking of that, some of the analogs, real quick, years that this looks similar to, are you familiar? Of course you are. Like off the top of your head, what are some of the analog years that we can say, well, this seems a little bit like, and remember, it's just analogous. It's not an exact match, people. We bring up sometimes 05, 17. You see people talk about 2013 sometimes, and that was a very strange year. So what analogs are we looking at for this year that can help us maybe as a little bit of a guidepost?
Yeah, so some of the analogs this year, as we work our way through the next couple of months, as you'll see at the top of this image, I have picked a few of the most active hurricane seasons and how the velocity potential pattern looked. And we can see that there was a pretty good match, years like 2017, years like, as I pull up on my telephone here, I have this little table that I keep
Right.
of analog years or years that I'm interested in that I always, that I'm now referencing. So I have in my list 2017, 2010, 2008, 2007, 1999, 1998, 95, and 1988. And those years in particular had many of those years would have had La Nina-like patterns. So that is what's driving the vast majority of those years. And certainly, as you'll know, Mark, there are some busy tropical seasons within.
Yeah, we got the buffering wheel. It's probably saying, hey, guys, it's time to go. Come on, don't do this to us. Well, maybe it'll catch up. I find it interesting at the top of this. So what you've done is you've picked out, whoops, got to get my iPad oriented the right way. This is the velocity potential from 17, 05, 04, 95, and 50. And it's interesting, there is that little sinking area coming off South America into the Atlantic, and yet 17, 05, 04, 95, and 50 were all pretty busy years. You know what I mean? And that's a similar, it's not like it's green all the way across the Atlantic. I mean, that tells you something.
Yep, and that's what we've seen so far this year, and that's
Right.
what we're expecting to see over the next 2 weeks. So there's a bit of a match there as we
Right.
look at the forecast, balance between the forecast and the analog. That feature is
That's
there,
striking.
and that has been a feature the last couple of years that has been there.
Right.
And it has not prevented the last couple of years from producing some very impressive hurricane activity.
Right. Agreed. All right. Well, anything else you want to add before we call it a day and let the internet do whatever it's going to do here as it tries to buffer us out?
Oh, I think we covered it all today, Mark. Yes, if anyone has any questions at all, feel free to at any time reach out on Twitter. Happy to answer any questions that you might have about the weather or climate. Both in New Zealand and abroad, in the U.S., the tropics. You can be anywhere in the world today, and I could be in Scott Base, Antarctica, and still be forecasting the hurricane activity for the Atlantic, and that's the amazing thing that of living here in 2020.
Well, this is Ben Noll's Twitter. It's at Ben Noll Weather, Noll. Follow him. Again, he's in New Zealand. And let me get you back on the Zoom. That's his picture from his Twitter. And
all right.
We'll say goodbye and let the buffering. I'm just Elon Musk. If he can bail us out with that Starlink and we don't have to worry about this anymore, I'll pay double what I'm paying now. I mean, come on. It's so frustrating. You see the little wheel? I see it. There's a little wheel going around telling me that it's buffering. Anyway, it is what it is. Hey, everybody, it's great that we had Ben. It's trying to just completely shut me off. It's great that we had Ben on. I appreciate his time. You're going to hopefully do something fun there this weekend in free New Zealand. I just want to mention that real quick. Not going to get too deep into it, but you guys... You've had quite an accomplishment there.
Yeah. Obviously we benefit from being geographically isolated, but there was a very strong push to go hard, go fast, early. We did have some cases here in New Zealand, but we did a lockdown that was about 4 weeks long, and people really, I think, abided by the rules, generally speaking, and that has put us in a place to be with a company of a very few nations that have that status right now, where no masks, no distancing, there is no community transmission of the virus here. So we will try to preserve that for as long as possible,
Sure.
And I'm not sure how long that will be, but we'll certainly try.
Have you been to a movie anytime recently? Are those open? I missed that.
Movies are open. I'm going to the gym here in the next hour, and gym classes. People are right next to one another. Spin classes on the bikes. Heavy breathing. You're right next to people. There is no restrictions whatsoever at this point. You could be in a bar watching sports. Food, restaurants. Malls, it's all pre-COVID here, basically. And again, we hope to preserve that, but eventually, if you introduce international travel to a place, which for New Zealand, that is something that could trigger more cases. But right now, they quarantine people on arrival, so you must remain quarantined for 2 weeks and present yourself with 2 negative tests before you're allowed to re-enter the general public. So that seems to be working pretty well.
Well, congratulations to New Zealand, and Ben's getting married at some point, and hopefully this can all go away so that he can really enjoy that, because that's a momentous occasion coming up for you and the bride-to-be. And again, congratulations on that. We're looking forward to that in the future.
Yeah, thanks a lot, Mark. We've had to change some plans a little bit with international travel, of course, as you'd expect. But yeah, I appreciate that, and it's going to be an exciting couple of years, no doubt. Interesting
times ahead. Well, everybody, that's going to wrap it up for this oftentimes buffered edition of Hurricane U. I appreciate it. We got through the meat and potatoes of it without any issues, and that's awesome. Thanks to the folks that did the little donation thing on the YouTube. That's always much appreciated. And again, thanks to our patrons who make this possible for this to be my job and we get to tap into somebody like Ben, whose job it is to forecast Valley, and all of us following him now on social media around the world on the tropical stuff as well. I'm going to try to sign off here before this just completely hate the circle. I am Mark Sudduth, HurricaneTrack.com. Thanks everybody for tuning in. I appreciate it. We'll talk again soon, I am sure. If I can get out.